Hello everybody, welcome back. I hope you're just as excited as this penguin is about our third solutions unit lesson. Last week we had a lesson on an introduction / background to solutions. We then had a lesson that would answer this question: how can we determine which compounds are soluble in water? And we used table F for that. Today, we are going to focus on this question: how does temperature impact the ability of water to dissolve substances? And we're going to be going on to table G today. Now, this was shown to you last week. And just a quick reminder, right? There are a number of factors impacting solubility: the like dissolves like rule, temperature, pressure, and these factors are dependent on whether we're looking at gases or solids and liquids being dissolved in water. Today is May 11th, and we are focusing on solubility curves, and you're going to need table G out. And please be aware that solubility curves demonstrate the amount of solute that can be dissolved in 100 grams of water. Now, before I show you the Regents reference table G, I have a simplified version of a solubility curve, and there's some important vocabulary that you need to know. Saturated solutions, unsaturated solutions, and supersaturated solutions. Now, on this solubility curve, you're always going to have temperature on the x-axis and grams of solute per 100 grams of water on the y-axis. And the curve here represents if there's any point along the line is what we would call a saturated solution. And that means the water has the maximum amount of solute at a given temperature. Any area below this line for that given substance means that there is less than the maximum amount of solute. Therefore, the water can hold more solute. And then finally, any point above this curve for a given substance is a supersaturated solution, and that means that the water is holding more solute than it actually should. And it's actually an unstable condition. And I'm going to have a video to go along with this lesson for you to see what a supersaturated solution looks like. They're pretty cool. Okay, so looking closely at table G, you've got, again, the solubility in grams of solute per 100 grams of water, and you have the temperature here. But now we have lots of curves here. So, and we have identified different solutes. So potassium iodide, potassium nitrate, ammonium chloride. All of these are different types of solutes that can be dissolved in 100 grams of water, and we would read at different temperatures at which they can be dissolved. Now, you'll also notice that the majority of these are, curving up. And what that means is, right, the higher the temperature, the greater the solubility. But you will see that there are several that show a decrease in solubility as temperature increases. And hopefully you'll recall from our lesson last week that that's referring to gases.
Carbonated beverages have carbon dioxide gas in solution, and they are a good demonstration of how the solubility of gases is impacted by temperature. I like my soda cold. Can you tell which soda is the one I'd like to drink?
let's look at a few examples here. And a typical Regents question would ask you this: how much solute can be dissolved in 100 grams of water? So let's look at potassium nitrate at 70 degrees Celsius. We go to 70 degrees Celsius. Here's our potassium nitrate. We're going to go up and read across. And we're looking at approximately 135 grams of potassium nitrate can dissolve and create, by the way, a saturated solution. If I had, at 70 degrees Celsius, what if I had 150 grams of potassium nitrate? Well, that's above the curve. And that would be a supersaturated solution. In fact, if we look at this curve for potassium nitrate, any conditions that fall here above that curve would be a supersaturated solution of potassium nitrate. Likewise, any conditions below that curve would be unsaturated. Okay, let's look at the next example. Ammonium chloride. At 90 degrees Celsius, we're going to read up to the curve. Here it is. I'm going to read across, and we're looking, I don't know, about 72 grams. All right, how about sulfur dioxide? There's the curve down here at 50 degrees Celsius. Reading up, not much to go here. It's only about 5 grams. And my last example here, sodium chloride. Actually, looking at sodium chloride, it's kind of almost flat. So what does that tell me? That tells me that the temperature does not have a heck of a lot of impact on the solubility of sodium chloride. And when we're at 100 degrees, we're cutting right across here, and we have about 40 grams, and these are all saturated conditions. That is the maximum number of grams that could be held in 100 grams of water. Now, the Regents can get a little tricky sometimes, so you want to read the questions very carefully. So we can ask a similar question, but the amount of water is different. So be careful. When you're reading directly on these curves, we're at 100 grams of water, not 50. I've selected the same solutes and the same temperatures just to make a point here. Well, if 135 grams will dissolve in 100 grams of water at 70 degrees, but I only have 50 grams of water, we know it's only going to be half of that. So really, there'd only be 67.5 grams. Likewise, we're only going to have half of this amount able to be dissolved. With your sulfur dioxide, only half. And finally, with your sodium chloride, only half will dissolve at 20 grams. Could the Regents ask about 200 grams of water? Absolutely. And you're just going to double it to 70 grams. In this case, 144 grams, 10 grams, 80 grams. Be very careful in the readings of the questions. That concludes our lesson on the solubility curves. That's Table G. I hope you have a wonderful day. Thank you. Bye.